Here is another very important concept dealing with complex numbers. If you have a complex number, z is equal to a plus bi. We can also come up with another number. I'm going to call it z bar. And the only difference between z and z bar is that z bar is a minus bi. This is called the complex conjugate of z. This is the complex conjugate of z. You have probably seen conjugates before. Remember in calculus, when simplifying algebraic expressions as part of taking limits, you would often have something like this in the denominator, and then you would multiply the top and bottom by something like this to get rid of the square root. And it worked very well. So we will use the conjugate, the complex conjugate, for very similar reasons here. Let's take a look at what happens when you multiply z and z conjugate together. And this, by the way, is our first example of multiplication of complex numbers. So if I take z times z bar, that's a plus bi times a minus bi. The way multiplication works is the way you would expect it to work. You're basically foiling a times a, and a times this, and then this, and then this. So let's go ahead and do this. We have a times a is a squared, and then minus abi, and then plus abi, and then finally minus bi quantity squared. So don't forget to put the parentheses around the whole thing, and the whole thing is squared. So now we simplify. A squared remains. Now these two cancel out, and we have minus the quantity bi squared. And it pays off to be careful at this point. Let's square bi. That's b squared times I squared. So we still have a squared minus b squared remains. But what's I squared? I squared is minus 1 by the definition. And so what we actually end up with is a real number, a squared plus b squared. So it's important to remember that if you take a complex number and its conjugate, you multiply them together, you end up with a real number. This will be very useful to us later. But for right now, let's make another observation. Does this remind you of anything that we have just seen in one of the previous videos? Remember, we had the magnitude or the absolute value of the complex number. We can write the magnitude of z is equal to the square root of a squared plus b squared. Remember this? So now this part right here is identical to this part right here. So I can say that this is the same as the magnitude or the absolute value of z squared. And so now we have an important relationship. We have this right here, z times the conjugate of z is equal to the absolute value of z squared. And it's always going to be a real number.